We're still in part 2, but now we'll talk about the solution of the differential equation. So as we said in the previous video, so we got the solution of the differential equation of the horizontal spring pendulum was of the form x double prime plus k over m x equal to 0. The aim of this differential equation, we find it in order to give the solution. If we have the solution of this differential equation, this means I can have the position of the object at any instant, which is x in terms of time. Now, the solution of this differential equation is of the form x will become of the form x equal xm sine omega 0 t plus phi. It's in math of the form y equal y maximum ax plus b. So this is in sine ax plus b. This is its form in math. Now, when I talk about xm, this means it's the maximum amplitude of oscillation. As for x, it's the position of at any time. So, for example, at t equals to 1 second, etc. When I talk about omega 0, it's the proper angular frequency. So usually we have that the frequency, we said the frequency is equals to 1 over t or equals to n over t. For the angular frequency, so it's omega 0, it will be equal to 2 pi times the frequency. Since I'm using here the sine equation, which is periodic and of period 2 pi. Now, as for the phi, it's the initial phase angle. And now we'll talk how to find this initial phase angle. Omega 0 t plus phi, all of it, we call it the phase angle at any time. Now, if the question was show that x equal xm, omega 0 t plus phi is solution of the differential equation. So how do we verify it? We have that the solution of the differential equation is x double prime plus k over mx equal to 0. So how to verify? We simply substitute, but I have x, I must find x double prime. So x prime is equal, we'll do a derivative here, derivative of xm sine. So we'll get xm cosine, and we have the omega 0, so put it here, and cosine omega 0 t plus phi. Now, as for the second derivative, so we'll get the derivative of the cosine, it's minus sine. So we'll get here minus omega 0 square xm and sine omega 0 t plus phi. Now, the question is to verify that this is a solution. So we'll do a substitution here. So we'll get minus omega 0 square xm sine omega 0 t plus phi plus k over mx, so put x, which is xm sine omega 0 t plus phi. Is it equal to 0? Must verify it. Now, we said that omega 0 is equal to radical k over m, which means omega 0 squared is equals to k over m. So here, I can substitute by k over m, I can put omega 0 squared. So we'll have here minus omega 0 squared xm sine and plus omega 0 squared xm sine, which is equals to 0. So 0 equals to 0, then it's verified. This means x equal xm sine omega 0 t plus phi is a solution of the differential equation. This means I can use it in order to find the position of the object of the mass at any instant during its oscillation.